Hello, I'm Lee Clayberg, and for my final project in computer graphics, I have decided to do terrain generation. My terrain generation uses a Perlin noise function which creates a smooth and realistic effect. The user can generate a new random terrain by pressing the 1 key, decrease and increase the level of detail using the 2 and 3 keys, and decrease and increase the steepness of the terrain using the 4 and 5 keys. The terrain is very detailed, so there is a slight delay between the pressing of the keys and the change to the terrain. I have also included a movable camera for checking out the terrain, and the user is able to view the wireframe of the terrain by using the W key. I also created a custom shader that, depending on the steepness of an area, changes the texturing. There are no sharp transitions between the textures to add to the realism. I have also added snow, which can appear on the tops of the highest points by using a custom function in the shader. So now let's dive into the code. One particular area that was difficult to get right was the texture changes depending on the steepness. My original way of tackling this problem was by using the normals of each triangular face. However, when doing this, there were sharp transitions between textures. Even using a function to try to blend the textures together didn't pay off. Remembering the lab where he colored a triangle, I tried to use the blending effect to my advantage. Instead of using the normals of the faces to designate the texture, I would average the normals of every triangle that uses the vertice. As seen here, every time the vertice is used in a triangle, the calculated normal using the cross product is multiplied and normalized with the current normal value for the vertice. This made the geometry much more complex, but would create the look I was trying to accomplish. I had to change a few other classes along the way, but the fragment shader is where a lot of the work is done. The shader calculates the angle between the normal and the up vector. Then, a few more operations are performed to pick and blend the textures. Another element I wanted to quickly touch on was the snow. I included a relative height field that I passed from my terrain generation to the fragment shader. In the fragment shader, the value is run through this function, which decides the intensity of the snow. Then, this is included in the final calculation of the texture. Finally, I wanted to talk a little bit about the camera and how to use it. The mouse controls the looking direction of the camera. The up arrow moves the camera in the direction the user is facing, and the down arrow moves the camera in the opposite direction. The right and left keys move the camera right or left with respect to the looking direction of the camera. The comma key moves the camera down on the y-axis, and the period moves the camera up on the y-axis. So that pretty much wraps up the overview of my project. I have included photos depicting the variable degree of detail that can be achieved with my project on the GitHub repository. Feel free to check it out, and I hope you enjoyed.